Okay, this video we're going to be talking about radians, and radians are units used to measure angles. Now, up to now, the units we've been using to measure angles are degrees. Well, radians are another way of measuring angles, and in certain situations, radians are a lot more useful than degrees. So, to start thinking about radians, I want you to imagine a circular lake, and imagine that you're going to take a walk around this circular lake. All right, now, let's say that this lake has a radius of 3 miles. And you're going to start right here on the shore of the lake, and you're going to start walking around the lake, and maybe you're going to walk, let's say you walk about 4 miles around the lake, which takes you to about this point right here. And you would like to know what is the measure of the angle, this central angle in this circle. What is the measure of the angle that's cut out by this arc that you've just walked around the lake? We're going to call this angle theta, which is a circle with a line through it. Theta is just a Greek symbol that's often used to stand for an angle. And in order to measure this angle, if we had a triangle or a right triangle, we could probably measure this angle in degrees. But we don't have a triangle, we've got a circle here. So we can measure this angle, theta, in radians. And the measure of this angle theta in radians is just the distance walked around the circle divided by the radius of the circle. Now, you may recall that this distance around a circle, this piece of a circle, it's also called the arc length. So essentially what we're saying is that an angle measured in radians is just the arc length divided by the radius of the circle. So for this particular angle here, theta, I know what this arc length is, the distance I walked, that's 4 miles. And I know the radius of the circle is 3 miles. So the measure of that angle would be 4/3 radians. Now, if I wanted to, let's say I kept on walking, I wanted to walk a little bit farther. Say I walked on, let's say I walked another 4 miles, and that brought me to this point right here on the lake. Well, this would give me another angle. Let's call this angle alpha. That's another Greek letter. And if I wanted to measure the angle alpha here that I've walked around the lake, then I could measure that. Alpha is going to be equal, again, this is in radians. It's going to be equal to the distance that I walked. Well, this distance that I walked here, we're going to say that's 8 miles. The distance I walked is 8 miles. My radius, the radius of the lake, again, is 3 miles. The miles cancel out. And so the measure of this angle here, angle alpha, for an 8-mile walk, that angle would be, or that angle in radians, would be 8/3 radians. Now, if I wanted to know the distance around the whole lake, in other words, if I started here and if I actually walked around the entire lake and I wanted to know how far that was, well, since my lake is a circle, remember that the distance around the whole lake, we're talking about a circumference, since it's a circle. And I know how to measure the circumference. The circumference of a circle is equal to 2 pi times r. Well, I know what r is. The radius of this circle is 3 miles, so the circumference, that is the distance around the whole lake, is going to be 2 pi times the radius, which is 3, which is 6 pi, and this is in miles. So that would be 6 pi miles. And now if I were to punch this into my calculator and get a decimal approximation for this, I would get 6 pi miles is equal to approximately 18.85 miles. So if I walked all the way around the circle, that's how far I would be walking. I'd be walking 18.85 miles. Now, if I wanted to measure that angular measure around the whole circle, angular measure, let's say the angular measure around the lake. Well, if I was going to measure this in degrees, that would be easy. I would know all the way around the circle, that's 360 degrees, right? Well, if I wanted to know that angle measure in radians, well, I have a formula here that I can calculate the measure of an angle. If I go all the way around the lake, let's call this, let's say, theta around the whole lake. Well, my definition of radian measure is arc length divided by radius, or if you rather say distance walked divided by radius. Well, if I walk around the whole lake, I've gone 18.85 miles, or actually I'm going to write it in terms of pi. I'm going to say I've gone 6 pi miles. That'd be the distance walked. The radius of my lake is 3 miles. And if I reduce this, 3 goes into 3 once, 3 goes into 6 2, then this gives me a radian measure of 2 pi radians. So the angular measure for a walk around the entire circle is 2 pi radians. Well, notice that the angular measure all the way around the circle is 2 pi radians. It's also 360 degrees. So notice that what I've got here is I'm essentially saying 2 pi radians is equal to 360 degrees. So I've kind of got a little equation here. In fact, I could, if I divide both sides of my equation by 2, then I can reduce this and say pi radians equals 180 degrees. Well, this relationship here, since pi radians is equal to 180 degrees, I can use that to come up with a conversion factor, which I can use to convert measures from radians to degrees. That conversion factor, remember when we talk about a conversion factor, I need something that equals 1. Well, pi radians over 180 degrees equals 1. So I can use this as a conversion factor. I might also want to use 180 degrees over pi radians. That also equals 1. So I can use this as a conversion factor, depending on whether I want to convert from radians or degrees. So let's take a look at some examples where we want to convert from radians to degrees. Example number 1. It says that the measure of an angle is 4/3 radians. What is its measure in degrees? So I want to convert from radians to degrees. Well, in order to do a conversion, I know I just want to multiply my value times 1. I don't want to change the value of my angle measurement here. I just want to convert it to a different form. Well, what value of 1 do I want to use? I want to use one of my conversion factors that I just came up with. I want to use the one that's going to allow me to cancel out my radians and be left with degrees. Well, which one is that going to be? 4/3 radians times, if I use 180 degrees divided by pi radians, then notice this allows me to cancel out my radian units and I'll be left with degrees. And so now I just need to do some arithmetic here. This would be 4 times 180 divided by 3 times pi. This is going to be degrees. And if I punch that into my calculator, I get a decimal of 76.39 degrees. So 4/3 radians is equal to 76.39 degrees. Let's do example number 2. If the measure of an angle is 70 degrees, what is its measure in radians? Okay, well now we're starting with an angle not in radians but in degrees. Now I want to convert this from degrees to radians. Well, again, I'm going to multiply it times 1. And what form of the number 1 do I want to use? I want to use the form of 1 that's going to allow me to cancel out my degrees and be left with radians. Well, that is going to be 180 degrees in the denominator. I want pi radians. This is the conversion factor. Pi radians over 180 degrees. This equals 1. And if I multiply this times my 70 degrees, my degree units cancel out, and I have 70 pi over 180. And this is in radians. Now, I can leave this in this kind of fractional form with pi. If I divide top and bottom by 10, then that's going to give me 7 pi over 18 radians. And you often see radian measures given in terms of pi and also in a fractional form. So this is a form of the answer that you might see. You could also punch this into your calculator and convert this to a decimal answer, in which case it would be 1.22 radians. Now, let's talk a little bit about negative angle measures. Now, up to now, most of the angle measures, in fact, probably all of the angle measures that you've seen have been positive angle measures. In fact, most of the time, you see angles like in terms of a triangle. And each one of these angles is going to have some positive angle measure. And it doesn't really make much sense to talk about negative angle measures when you're talking about a triangle. There's no negative angle measure that you can have for a triangle. Well, when suddenly you're talking about angles in terms of a circle, like the circular lake that we talked about, you can have negative angle measures. So imagine that you've got this circle here, and here I put it on a set of x, y axes. So the center of my circle is here at the origin. And now, if you can imagine kind of taking your circular walk around this circular lake again, and if you walk up to this point, say right here, then this angle, let's say this angle is 60 degrees. More specifically, we would say this angle is a positive 60 degrees, and that's because the convention is for labeling angles as positive or negative. If you are walking around your circular lake in this direction, these are going to be positive angles. Whereas if you are going to walk around your circular lake in this direction, these are going to be negative angles. So if I walk around my lake up to this point right here, this would be a positive 60-degree angle. If I were to walk around my circular lake in this direction, say I went to right here, the measure of this angle here would be negative 90 degrees. If I were to start right here and walk around my lake to this same place here, well, now this angle here is not going to be negative 90 degrees. This angle right here is going to be positive 270 degrees. Even though I ended up at the same place as far as the angle is concerned, this would be negative 90 and this would be positive 270. Now, you can see there in your notes, it asks you to convert each one of these angle measures from degrees into radians. And you already know how to do conversions from degrees into radians. You just have to multiply by the correct factor, the correct conversion factor. So I'm going to leave you to do these three examples on your own. You've got two positive angles and one negative angle. So convert those into radians, and we'll take a look at these in class tomorrow.